to welcome you all to the online faculty development program on emerging technologies on biomedical healthcare application. On behalf of Satyabama Management and Department of Biomedical Engineering, I welcome our today's guest speaker, Dr. S. ATHEENAPANDIAN, COE and Managing Director of ATHEENAPANDIAN Private Limited, Chennai and Courtallam. Sir has started his journey as a biomedical profession, and he has in year 2016, he has started various online courses on biomedical subjects, and he also launched a separate channel for biomedical engineers through YouTube channel named ATHEENAPANDIAN. And in 2017, he published a biomedical books through the International Notion Publishers. And in 2020, he evolved ATHEENAPANDIAN Enterprises to ATHEENAPANDIAN Private Limited at Courtallam. And in 2021, he established ATHEENAPANDIAN second branch at Chennai. And he is also inaugurated Povia Z Biomedical Association to connect the biomedical community across the world. Sir has published more than 348 biomedical related videos in YouTube channel, and he also published 154 biomedical articles through his website, atheenapandian.com. Three of his books were translated into the prestigious languages Persian, and he also published more than 100 biomedical related PowerPoints through the LinkedIn slideshare.com. He also has the teaching experience as well as the industry experience. He has received a Best Faculty Award in 2015, 16, 17, 18, 19 from the management of Agni College of Technology, Chennai. He also received a Best Motivator Award from the Placement Cell of Agni College of Technology. 3 times he was honored with Dr. Radhakrishnan Award in the year 2018 for the Project Excellency from Kalam Club, Chennai. He also won the Indian Achievers Award in 2021 from Indian Achievers Forum, New Delhi, India. He has received a Star Golden Award 2022 from the SAT Group of Organization, Telangana, India. And he also received Educational Achievers Award from the International Anti-Corruption and Human Rights Council, recognized by the Government of India. He also a director of ATHEENAPANDIAN Private Limited. As a director, he has signed MOU with 45 engineering institutions and 10 multi-speciality hospitals and 54 biomedical industries in all over the world. Until November 2022, he has done so many MOUs. We are also very happy that we also have signed MOU with ATHEENAPANDIAN Private Limited, sir. We welcome you for the today's session, sir. Handing over to you.
Yeah. So thank you very much for the introduction, madam. So shall I proceed, madam?
Yes, sir, you can start. Yes, sir, please.
Yes, thank you. So now I'm just, thanks for the introduction, first of all, and thank you to the management of Satyabama institutions, and thank you to the department, head of the department, and all the other faculty members who are inviting me for this wonderful faculty development program. Now, today, actually, first of all, I just apologize that because I gave the name for yesterday's presentation, but unfortunately, because of some other commitment already I made, I can't able to come over there and present yesterday. But now I am ready to give some of the important innovation techniques regarding the biomedical engineering is concerned. In this particular biomedical engineering innovations, in this particular biomedical creations and the strategies, there are so many things are included. You know, something for the past 20 years, when compared to the 30 years back, what actually the innovations in healthcare is entirely differ in past 15 years. Because the development of the healthcare is enormous. And at the same time, the company startups count, the devices counts is keep on increasing. You know something, in the 2000 period and 2005 period, the count of the equipment is under 10,000. You know something, in this 15 years, the count of the equipment is rise to 29,000 according to the FDA. So according to the Food and Drug Administration, almost 29,000 biomedical equipment are there in all over the world. The reason behind this, everyone is rushing towards the healthcare. The customer count when compared to the other domain, you just compare to the automobile or electrical or communication, or it can be to go for IT, whatever it is. The customer count is enormous. The reason behind this, each and every person in the world is considered as a customer of healthcare. The person is from the herds, or person is from the highly financial worth people, or whomever it may be. If there is any discomfort in their human body, if there is any discomfort in their daily basis activity in their health, they straight away come into the healthcare domain for getting some assistance to clear that disorders or disability. So that is the reason why every one of the person in the world are considered as a customer. So once you are targeting a minimum count of the customer, the more number of innovations required. But the healthcare is concerned, the world is as like as a customer. So the customer count, the customer areas, the area coverage is almost very, 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 very high when compared to all the domain. So that is the reason why the recent innovations are required to target them. Because the community of the people, and the food intakes and their environment, their atmospheres are entirely differ from each and every region of the world. The climatic changes, the seasonable changes in the climates, and their the traditions and their food heritages, all the things are because of that particular changes there. The healthcare support and the health activities are also differ. So that is the reason why the innovations are required in each and every regions particularly. You know, I hope so. These particular thing everyone knows. In 2019-20, most of them are arrested because of the COVID. In the 1960s and 1970s period also, in the European and American countries, this particular COVID is identified. This COVID virus is actually identified in that regions. But what is the reason why they are not spreaded over in the community is the strength, the ability of the human beings in those periods is enormous. Their food intakes, their hereditary, their environment, their atmosphere is entirely welfare and very wealthy. That is what the COVID virus are can't able to do anything in the atmosphere. But now everything is totally changed. The environment is polluted. The food intake is entirely different from when compared to the 15 to 30 years back. So that is the reason why the pathogens are easily incorporated in our human body. So if you are competent in that particular pathogens, if you are competing all these pathogens or all the disabilities and disorders, we need to have some of the innovation techniques. Once the new innovations are required only, we can able to target these kind of the pathogens and the newly disorder and disabilities. Even though we are in the modern healthcare technology, there are so many diseases and disorders didn't have any diagnostic tools or therapeutic treatments available. When take an example of ophthalmology and the craniology, almost in ophthalmology is concerned, there are over 24 diseases are there, disorders are there. But still only 13 disorders can able to find out using the diagnostic tool. Still 11 or 12 or 11 diseases and disorders of the ophthalmology is can't able to find using the diagnostic tools. Through the symptoms only doctors can able to identify all these things. Especially we can able to take the retina pigmentosis. That is the disease that they don't have any diagnostic tool to identify. Through the symptoms only doctors identified. The main symptom of that particular thing is the vision is slowly getting down because of the pigments of the particular person, that is especially the eye pigments of the particular person is got reduced, the rods and cones. The person having a count of rods is getting reduced, then the persons are considered as the retina pigmentosa person. The persons are can't able to see the objects in the night, but it is not as like as a night blindness. This is what the meaning is. So the night blindness is entirely different from retina pigmentosa. The night blindness can easily identified by using a diagnostic tool, but retina pigmentosa is different from night blindness. But still there is no diagnostic tool to identify. Through the symptoms only doctor can able to identify during the night time. You can able to see some of the objects, so it is not considered as a night blindness. It is a retina pigmentosa. So like that, almost 11 to 12 diseases and disorders are there requiring diagnostic tools to identify the particular disorder. As like as an ophthalmology, cranial is also, and the nephrology is also. So even though we are in the modern technologies, these particular disorders are can't able to be. That is what the innovations required. That is what the advancement is required still. In 2019, in 2018, 19, 20 period alone, FDA is approved almost 1,594 new devices actually. Approved by the new medical diagnostic and therapeutic devices. In that, almost 73% of the equipments are relating to the respiratory and cardiology because of the COVID. And one more most important thing is that the 82% of those particular equipment are the students' projects. And one sad thing is that none of them from the Indians. None of the Indian projects are selected to convert into the product. Because of that particular reason why, even though in a multi-speciality hospitals in nowadays, in Apollo hospitals, you can able to take an example, the 90% of the equipments over there in Apollo hospitals are imported. They are getting the equipment from the abroad countries. They are getting the equipment from the Tier 1 companies. For the past 20 years, the top 15 Tier 1 companies are there. They repeatedly they are picking the same part. The top 15 biomedical companies. You can able to take it out the G Healthcare, Johnson & Johnson, Siemens Healthineers, Stryker Corporation, Baxter International, Fresenius Healthcare. These are all some of the things. Medtronic. All these particular Tier 1 companies are repeatedly coming in the top 15. Their position is changed, but the company's list is same as the past 20 years. So all these companies' products are there in Apollo. But all these companies are not from in India. It is from European and US companies. So what my point is, if you are go and search in their articles of their own website, you can see some of the higher officials, they are working under the top 15 companies. Shockingly, the 90% of the people are Indians, the higher officials, the head managers, the national managers, the leading marketers, the manufacturer head, the testing and quality operations head. All these people are Indians. So even though we are getting into the advanced advanced technologies are used here, and most of the companies, they are manufacturing the product, they are selling their product, especially, that is particularly in Indian market, because the innovations are welcoming in India, but innovations are not created in India. So these advanced techniques are included. These advanced techniques are there in India, and all over the world it is spread over. But the most important point we need to notice, all these innovations are coming from outside, not from India. I will give you some of the clarity about which are all the innovations that is coming to India, which are all the innovations still we are waiting, we are welcoming, and why not we are not creating all these innovations because of the lack of exposures. Even the final year biomedical engineering student from many of the institutions, many of the universities, they didn't know about the exposure about biomedical. So that is the reason why we are not able to innovate. So we must have an exposure about all these innovation techniques and all, and then only we can able to approach this to the students to develop their project into the product. because there is no destination point for the project. The project is not completed anywhere. Whenever the project is converted into the product, that is a destination point of every project. There is no mini project and major project medics. The project having a destination point, only the project is converted into the product and sent into the market. But many of our students did that. The destination point is a viva voice. Once the viva voice is getting over of the project, then the project is having a destination point, it is completed. But what we are going to prepare is the project having a destination point, only the project is coming to the market. So that is what we are supposed to prepare. So now I am going to say some of the innovation techniques, advanced innovation techniques in the biomedical. Of course, many of the experts, they know about the innovations, but in deeply, if you know about the innovations, that will be help you for the people, those who are having a passion towards biomedical innovations. So coming to the next part, I'm just comparatively from 1895 to 2022. I hope the slides are changes, right? I'm going to get into the second slide now. Are you able to see, right?
Yes, sir.
The slides are changing, right?
Yes, sir.
Because I'm not aware about this Zoom and all, because we are keep on using this Google Meet. That is what I have a doubt. The slides are changing, right, madam?
Yes, sir. It's changing, sir.
Yeah, thank you. Thank you. So the innovations, the biomedical innovations from 1895, what is the reason why I'm indicating the 1895 is? After the innovations of the X-ray, after the innovations of modern X-ray, after the innovations of radiology, especially the William Conrad Röntgen, he introduced X-ray. After the innovations of X-ray only, all the scientists having a curiosity to know about the internal organs. Because in the before 1895, the doctors are studying about before 1895, the doctors are studying about the internal organs through the cadaver. The cadaver is nothing but the dead bodies. Through the dead bodies only, the doctors are able to know about the heart visibility and the internal parts, everything. Once the X-ray invention is getting over, then every scientist having a curiosity, oh, through the living bodies also, we can clearly viewing about the internal bodies. Then only after the invention of the X-ray only, the imaging is coming play a role in it. You know something, 57% of the medical devices in the world are imaging equipments. Most of the 90% of the doctors requiring the imaging equipment only to diagnose what sort of the disease it is, to diagnose the exact condition of the diseases and the disorders and disabilities. So imaging equipment are the more diagnostic tools in the healthcare devices. The reason behind is after the invention of this particular thing only, now we have the portable imaging system in your mobile phone. There is a portable probe is there. Instead of using the probe in the ultrasound machine, we have connecting the probe in our mobile phone. Through the probe, we can see the heart very clearly through the mobile phone. That kind of the advancement we have. But who is putting a seed? Röntgen. So that is what I mentioned here. In 2000, after 2022, there are so many innovations are waiting to come. So many innovations are there. You know, of course, many of them having a probably used it in LinkedIn. Last week, I saw the video that is called as an artificial womb. Artificial womb is there. Artificial uterus. Almost 30,000 babies are developed without any assistance of the parents. Without any assistance of the parents, the 30,000 babies are developed in an artificial womb. With that, what's the development is. So the initial process, the initial biomedical development starts from it, 1895. Okay, next slide. So then we are moving to some of the what happened in 1895 to 2022, which are all the areas that getting an advancement, got an advancement. Of course, in imaging. And secondly, medical robots nowadays. The Da-Vinci robot, the first made robot, Da-Vinci. It's introduced in California. It made almost 100 surgery completed. Now there are over 149 robots are there doing surgery in America. Still, there is not even a single robot is coming to the Asia. So that is what is the reason why I'm keep on mentioning about the discouraging. I'm giving the pessimistic talk about the healthcare in India is the innovations are entirely different in healthcare. That is what. Okay, and then the third is prosthetics. Prosthetic, PROS. The spelling mistake is that prosthetic, PROSTHETICS. So prosthetics, of course, the replacement of the organs, the aiding support of exposure in the limb areas, the forelimbs and the hind limbs. Particularly, the prosthetics play a main vital role, especially in Australia and New Zealand. There are over 1,000+ prosthetic companies are there, rehabilitation companies are there, because everyone is rushing to get some of the artificial organs because of the environment, atmosphere. Most of the accidents percentage is getting increased to 45% in all over the world. The reason behind is everyone is having vehicle now. So the accidental percentage is increased to 45. Because of that, more number of people require an prosthetics support. And then get into the 3D bioprinting. Yesterday we have a meet on 3D bioprinting, elaborately about it. So these particular 4 innovation techniques are developed from 1895 to 2022. Most of them get benefited. Most of them get benefited through this particular areas. Next slides. You know, once you are getting to the deeper about X-ray, proton therapy, and wearables, apart from these particular things, I'm just want to explaining about the development of X-ray. Everyone knows that X-ray, when a fast-moving X-ray, when a fast-moving electron is suddenly stopped by the metal target, it will emitting some of the rays called X-ray. Of course, everyone knows that. The thing behind is, through the electron transformation, through the electron movement, no, we are in advanced technology by using the probes in the phones. The 100 mA portable X-ray, we can able to keep it into the pocket. That all the innovations is. So, next to the X-ray, in 1972 only, after the almost 90 years, almost 80 years only, the next development will come into the market. That is called the computer tomography. The disadvantages of the radiology in X-ray will be overcome by using the innovations called the computer tomography. The 3-dimensional view of the internal organs can able to view. Can be done by the Godfrey Hounsfield, the scientist from Europe. And then the innovations coming after the 1973, in between that 1895 to 1973, the ultrasound is emerging out from 1958. The ultrasonography is coming to play, but it is not an imaging equipment. Initially, the sonography is coming for not imaging purpose. It is coming for the signal analysis. Through the waveform only, we can able to see. We can able to identify the babies inside and the internal organs viewment. And later, the invention of the sonography is coming to the imaging techniques in the period of 1980s, after the invention of CT. And then in the 1985 period, the magnetic resonance imaging is coming. Because of the exposure of X-ray is very harmful. Some of the patients having got a cancer in, especially in urban areas in North Japan. So because of the reason why the new innovations are required. So because of that, the MRI is invented by the Raymond Damadian from the England scientist. So after the innovations of the Raymond Damadian's MRI, then it is moving to the positron emission tomography. Then the single positron emission tomography. Then the positron emission tomography PET scanner is combined with the CT to get taking imaging. The cancer is keep on developing in the period of 1970s, 80s period. So the equipment, the tools are required to identify the diagnostic, the stages of the cancer. So the doctors are requesting the engineers to develop something. Because of that, the PET scan is coming out in the 1980s period. Then the PET scan is combined with the CT to get a 3D imaging of exactly what actually the depth of the cancer is. And then the SPECT scanner is coming out. So all these diagnostic tools are enough amount to diagnose what exactly the cancer is. And what is the next step required? The diagnosis, okay. Then go for the treatment. There is no any treatment is available for the cancer in 1990s period. And in the 2000 period, the first stage and the second stage of cancer can able to clear by using some of the therapeutic tool, the laser treatment. But laser is very harmful during that period. So the doctors are required much more tools to treat the cancer. That is what the next development, that is called the next topic, proton therapy. You know something, my dears? Proton therapy is manufactured by only 4 companies in all over the world. In that, the top company called IBA, ion beam application. You know something? In all over the Asia, there is only one proton therapy is available in 2017, up to 2017. That is there in Chennai. The Apollo hospital is the only hospital have this proton therapy unit in all over the Asia. Even the Russia didn't have, even the China not have, even the Pakistan, Bangladesh, Nepal, none of them have this particular, Japan, Korea, none of them didn't have this proton therapy unit. Only we have. The IBA sponsoring this proton therapy to Apollo. We have the unit at Perungudi. You can able to see very nearby to Satyabama. Proton therapy unit is there. You know something? The cost of that particular proton therapy is 25,000 crore. We can get the treatment of the cancer. The root level cancer can be treated using the proton therapy. It takes almost 30 days of time to clear the root level cancer. The cost of one cancer treatment is 30 lakhs. It is started in the period of 2018. Now the 100 patients are getting cleared from the cancer by using proton therapy. Mostly from the Bollywood artist from the Maharashtra and Madhya Pradesh. In particularly, the chest cancer, that is breast cancer, and the nephrology like of cancers, the abdominal cancers are cleared. It crossing 1,000, crossing 150 now in 2022 records. So this is what an advancement is. And then the next, the cancer are treated nowadays. Some of the cancers are not treated, especially blood cancers are can't able to be. Bone marrow cancers are can't able to be. But all the other tumors can able to cleared by using the proton therapy. But most of the upper middle class and the royal middle class peoples are can't able to come into play a role of proton therapy because of the cost is very expensive. But now the Ratan Tata is going to build this particular proton therapy in Bombay, in Pune. So the next unit is coming to play a role in 2021. They're going to start in 2022 at the end of December, I think so. So this is what the innovation is. So all these particular things as a student, as a biomedical engineering student might even know about it. Proton therapy. You know something? There are 4 different cyclotrons are required to creating the radioisotopes. My friend, all these information I can able to get. My friend, one of my classmate is there in proton therapy unit, Rajagopal Krishnamurthy. So he's giving all these kind of informations. I have a chance to visit over it. That kind of the mission, that it's just like an apartment. You can able to see the equipment as 3-floored apartment. The size of the equipment is 3-floored apartment. You can't able to imagine that kind of the medical equipment in my life period. That vast look kind of the cyclotron I can see. In that only the 5 biomedical engineers are there. The 7 radiographers are there. The 9 physicists are there. They are doing the surgery. They are doing the treatment for it. So this is what the innovation is. The doctors are giving treatment in 1990s and 2000 period. But now for the cancer, the radiographers and the biomedical engineers are giving treatment to the cancer peoples. This is what the innovation is. And then come to the point, after the X-ray, after the proton therapy, nowadays, the most booming topic is the wearable systems, the wearable devices. Almost 1,924 wearable devices are there in all over the world. because everybody is rushing towards their job. Everybody is rushing towards their money. Everyone is getting into the field. They're getting into the job market. Both the parents are working nowadays. So everyone is can't able to get into the hospital to get a treatment for 1 month or 2 months. Even for the diabetic patients also don't have any time to get into the insulin, to get into the clinics. So everyone is requiring a wearable systems. They just wear it and get into the office. And they check their medical, they are just monitoring their health vital parameters through their mobile phone. The Holter monitor is there. No need of a clamp electrodes and the 6 electrodes. That is 3-channel electrodes are there in lead systems are required for ECG. But through the Holter monitor, only 4 electrodes is enough to take the ECG readings. And the wearable watches, wearable bangles, wearable belts, wearable shirts. In that wearable shirts, we can clearly diagnose the pulmonology study of it. All the vital parameters of the cardia and your pulmona will be monitored by using the wearable shirts. The external defibrillator is there. We can able to wear it. And the diabetic is concerned. In 20 years, in 15 years back, in 5 years back, even 5 years back, once you want to get the insulin injection, we get into the clinic. But now there is no need. There is a pocket insulin is there. You just wear in the belt. Whenever you require insulin, you just set the alarm over it and you just press the button. The insulin is straight away get into the liver. That is what the development is. And innovation glass is there. Innovation glass. The people, those are having a myopia and hypermetropia, they can easily identify their power by using the wearable glasses and wearable rings. There are so many. Of course, I told you, 1,900 plus wearable technologies or wearable systems are there. All these innovations, in this wearable system, almost 25% of the wearable systems are recently approved by FDA. Recently approved by FDA. That is what the innovations is. The biomedical innovation is. Next slide. So come in detailed study of radiology is concerned. All the, I told you, the 15 topmost biomedical companies. In that, almost 8 biomedical companies, 8 topmost biomedical companies, they're manufacturing radiology equipment. Particularly mammography, mobile X-ray, PET CT, PET and SPECT. These are all the more selling product in the market. Because of this COVID, everyone is rushing to take X-ray. Because of the most vulnerable diseases spreaded over especially in European countries are breast cancers. So all the most of the tier 1 companies, they start manufacturing mammograms. So that is what the radiological development is. The 100 MA X-rays are also available now. 50 MA X-rays are also available now. There is not harmful anyway. Mobile X-ray is there. Portable X-ray is there. RVG is there. In dental X-ray, in dental, portable X-ray, dental, that is a cable called RVG, the radiovisiography. The radiovisiography is a small cable. It's a small cable. It's as like as only 15 cross, 5 cross 3 centimeter in dimension. 5 cross 3 centimeter in dimension, length and breadth. It is cost of around 1.5 lakhs. Just a small cable. Inside that, there are 9 different layers are there. It will do all the post-processing works of X-ray. That is available nowadays. The company called the Carestream. The Carestream is a company, they developed this RVG cable in 2011. Most of the dental clinic, you can able to see this RVG. RVG clinics are also there in some other part in Chennai. The RVG clinic, they put a title as RVG clinic. One RVG cable is just 1.5 lakhs. You can keep the cone beam X-ray in a part, it is 1.5 lakhs. The investment is only 3 lakhs. But you want to take a scan, you need to give at least a 3,000 or 4,000 per head. The time duration for taking the imaging is just 5 minutes. So most of the doctors, they start their business by introducing this RVG to the public. So that is what the innovation nowadays. The RVG cables. Okay, the next slide. Then proton therapy. Of course, I told you what you are seeing in the proton therapy is one single exposing unit. I told you, one single exposing unit is there. Of course, the radiations are keep on coming out from this. The radioisotopes emitting radiations. Keep on it is coming out in that atmosphere. So it must be most predictable. You know something? The scale pay of biomedical engineer over there in proton therapy is 2.75 lakhs per month. 2.75 lakhs per month. It includes, it excludes all your hospitality. The IBA company, ion beam application, is the only company they are developing this proton therapy. The IBA company is there in Belgium, actually. Then now the Google and GE start doing their project in IBA. Very soonly, Google is coming to play in healthcare, in ophthalmology and the cancer treatment. And of course, GE Healthcare, they start a unit to develop in Korea for cancer treatment. So all these particular thing, actually, the engineer should know. One small accessory in proton therapy, its cost of around 5 crore. That is what the basic requirement accessory. The basic accessory actually to make the 25,000 crore machine is 5 crore. The cost of MRI is almost there. So this is what the development is. We are the responsible people. The biomedical engineers are the responsible people to make it. At the same time, we are responsible to troubleshoot it, and we are responsible to calibrate it. And most importantly, we are responsible to send the radioisotope to treat the particular cancer to the patient. Not the doctors are involved here. The doctors are just diagnose how much amount of the depth the cancer is, where exactly the area is, how much amount of dosage you need to give us. That's what. Then all the sending execution process is done by the radiographer and biomedical engineer over there in the unit. So the students might even know about proton therapy. So still we are crossing the Kanpur book. There is a 12th edition and 13th edition is there. But still we are in the 13th edition. There is no updation over there. There is no included ophthalmology equipment. They are not included physiotherapy equipment. They are not included any innovation techniques over there in biomedical field. So that is what the students might even know about all these innovations. And the next slide. And then you go for the next thing I told you, right? Wearables. So wearable systems, even the electrical peoples, electronics and communication peoples, most of the institutions, they are encouraging to do some of the healthcare projects, healthcare relating projects. Because if you are, you know something, if you are applying for the patent, if you are doing projects in healthcare, if you are applying for the design patent or if you are applying for the product patent, it will be approved very, very quickly. Rather, you are not going for the, once your clinical trial is getting over, it will approve. So that is what we are just encouraging our students to do the project in healthcare, particularly in wearable systems or particularly in something like bioprinting or micro robots or nano robots. That will be converting into the patent very easily because the healthcare, because nowadays on MSME and the central government and some of the private non-profitable organizations are supporting or funding their for the healthcare projects. Because everyone is required for it. You know something about Joho. Everyone know that Joho Corporation. Many of them know that that is an IT company. You know something, there is a separate research spot for the healthcare in the Estancia building in Kattankulattur. In the Estancia building, there is, I think, the Joho Incorporation is there. In that, the separate area, the 1,500 square feet, they are doing the research in cardiology and respiratory. Very soonly, they are come and play in healthcare. They are going to make some of the wearable devices, especially for cardiology and respiratory. So just imagine all the domain people. Ford, of course, Ford is an automobile. Ford is an automobile, but they are manufacturing oxygen concentrator machine and oxygen tank for the past 3 years. They start manufacturing. Still there is a company called the Ford Medical Systems. Basically, they are an automobile company. Everyone knows that. HCL regulatory affairs is there. Medical regulatory. Wipro, GE. Infosys also come and play a role in healthcare very soonly. TCS having a healthcare role in. So that is what the reason. Microsoft, of course. Google has come to play a role in ophthalmology. They are particularly targeted Sangranetralaya in Chennai. So the reason behind this, everyone look it in the healthcare is for the business, because the customer count is very large. All the human beings in the world are considered as a customer. There are so many diseases and disorders are there. Even though the 29,000 biomedical equipments are there, still there is enough space to identify some of the diseases and disorders. So that is what most of the people, they start funding their money to manufacture the healthcare product. They are supporting many of the young engineers to develop a product in healthcare. If you develop the product, if you are approaching any of the company, whether the particular product is very helpful for the society, then the company picking you. The companies are ready to pay enough amount of money to take the product. So if you are sharing all this information to the student, they make the curiosity to make the product. They not stop the project till their revival. They are extended their project. They start their project from the third year itself, the starting of third year itself. Then it's enough time to make a patent. 48 months is required. 48 months is required. That is maximum level I'm talking about. So all these kind of the innovation techniques can able to make ours, because most of the higher officials are there in tier 15 companies. The tier 1 companies in top 15 in all over the world are Indians. So that is an innovation educational system is available here, but the approach where I need to work, where I need to spend my knowledge, where I need to work on, that kind of the exposure they don't have. Even though they are having a CGPA 9.5, whatever it is, the application oriented, where we need to apply all the educational background knowledge, where I need to apply that kind of the exposure we need to give, then we are also creating an equipment. The only equipment called the DOSE, DOZEE, the equipment called the DOSE, it invented by the IIT Bombay people. IIT Bombay people, they are inventing this DOSE machine. All over the world, it is well marketed. The cost of it is just 7,500 rupees. But it gives clarity to many of the elderly people. Just an IoT and embedded make a role on it. The small sensor is there. The PAT sensor is there. To monitoring almost 17 diagnostic, monitoring a diagnostic vital parameters in an elder people. Many of them are saved through the DOSE mission. You have a chance, you just make a Google it. You can see what DOSE is. That is an Indian product. Of course, innovations are there, but the count of the innovations still very low when compared to other countries. That is what innovations we must know to share to the students to make a project into the product. Next slide. Of course, medical robots. And keep on telling one small example I would like to say. That is enough for the innovations in medical robots. There is one robot is invented in India, in US, California. In many of the hospitals, it is spread out. That is an artificial intelligence based robot. That is, you know something, the whole body checkup will be done within 20 minutes. The whole body checkup will be done in 20 minutes. In the eye of the robot, there is a sensor. The sensor will monitor from the head to the foot of the patient. In front of the patient, in front of the robot, the patient need to stand over and enter the details in their chest using the pads, keypads. What's the name and what is the age and what is the gender and what is the address and everything. Once you are submit the form in the chest, then automatically the eyes are open in the robot. Then the robot look out from the head to the foot. It observes the patient internally, externally for almost 2 minutes. That is enough for monitoring. Once the 2 minutes are getting over, in the chest region, one display is getting on. In that, almost 29 vital parameters are displayed. And each and every one and each and everything will be monitored and each and everything will be displayed. How much amount of temperature you have, how much amount of oxygen saturation level you have, how much amount of pulse rate you have, how much amount of cholesterol level you have, how much amount of hemoglobin you have, all the thing, 29 vital parameters are displayed within 3 minutes of time. And then once you read over all the vital parameters, it takes 5 minutes of time. Then after 5 minutes, the robots are not allowed to get away. In the stomach region, in the abdominal region, one more monitor is getting open. In that monitor, which are all the things abnormal in the 29 vital parameters, it will be displayed. And which are all the precautions you need to take to clear the abnormality. That will be given. Orally, the speaker will be speak you. The robot will be speak you. This is the condition. You are having an abnormality in cholesterol. You are having an abnormality in type 2 or type 1 diabetics. You are having an abnormality in hemoglobin level. You are having an abnormality in something like that, whatever it is. So because of this particular region, you must be take care of this medicines. You must be take care of this particular food. This content is high in this food. So you can take this like that. Every information will be coming out. And you can able to take the printout of all these sheets also in the backside. And at the end of the 20 minutes, one report will be coming out through the printout. The 20 pages, the 20 plus pages are there. Everything will be coming. All this thing happen only in 20 minutes, my dear. But if you are going for the full body checkup in Apollo, it takes 2 days of time. But through the robot, we can able to take the full body checkup in 20 minutes. This is what available in California, in US, in most of the hospitals. That is actually a project of the Boston University students. Boston University students are famous for the biomedical engineering. And one more innovations from the NTU, the Nanyang Technical. All these things and innovations are happen in a medical robot is concerned. Next please. Of course, what you are seeing on the left side is what you are seeing on the right hand side is Darwin's. The first initial robots due to the cardiac surgery in California. Okay, I hope you can able to see. Next please. Medical robots, I told you, no, the robot, what you are seeing in the left hand side, that is called the robot. It will monitor the eyes of the robot having a high peculiar sensors. It will monitor all the, it will send some of the signals also, the ultrasonography signals. All the sensors will be kept over in the eyes. The eyes play a main role. The eyes take an inputs from your body, from the head to the foot, and the monitor will be displayed in the chest region. And some of the robots will sensibly having a touch over it to check your cranial activity. What you are seeing in the third robot. So all these innovations are available nowadays. Next, please. Then the last but not least, I think, the bio 3D printing. 3D printing, of course, everyone knows that in 1960s period, it starts for the construction business and we get into the automobile business. And now it is entering into the healthcare in the name of bio 3D printing. The technology where we need to give for the application. Initially, it coming for creating a model, the human models, for creating a human 3D model of the heart, 3D model of your lungs, liver, brain, kidney, and everything. But now it is used for the artificial organs creations. Once you are zoom it and you can able to see, I will zoom it. You can clearly see the application part, the 3D printing and the 3D bioprinting. If you are using the 3D printing for healthcare purpose, only for 3D printing, for the model creation, physical organ model. And for the purpose you are implanted into the human body, that is a separate thing that is called a bioactive tissue model. There is a 3 different processes there: additive, subractive, and formative. And using that particular process, the imaging will be taken, the images of the patient will be taken, the organ of the patient will be taken, and all this thing is converted into the STL file, the stereolithography technique. Then the file will be converted, and then layer by layer, it will be created. That is called an additive process, additive manufacturing process. Techniques are used to creating the artificial organs. So this is what the innovation is. This is what the creation is. Something, 7 to 8 years back, if you want to create an artificial heart, it takes almost 1 week of time. But using this bioprinting, 3D printing model, we can able to create an artificial human heart in 4 hours, just 4 hours. So this is what the innovation is. Next, please. See, and these are all the thing I shared. Next. Right. This is a process of the small example I keep here is artificial skin. I think base model. No need to zoom it. Okay. Yeah. So this is what the 3D printing model creation is. The artificial organ creation is. Take an image, whether it may be a DICOM file, or it may be a JPEG file or PNG file, whatever it is, converting that into the STL. And then the STL is the basic modeling file of processing file of 3D printer. And then converting. The most important thing is, once you are getting into the model, it is very easy. But once you are getting that particular thing for the artificial organ to implanting into the human body, it is more difficult, my dears. Because for that, you need to prepare a bio ink. Bio ink is the process. It will be created through the patient's tissues. Through the patient's cells and the tissues only, the bio inks are created. That is a separate study in tissue engineering. You can take that particular bio, you can create the particular bio inks. Once the bio inks is created, that is a deep study. Once the bio inks are created, then that particular ink will be injected into the bioprinter. That bioprinter use the additive process, manufacturing process. It will creating the artificial organ layer by layer. Once the process is getting over, then the created model, before it is getting into the implanted, then it is going for the biomechanics checkup, biomechanical checkup. That is the 3 different processes there. Totally mechanical, partially mechanical, and biological. Whether the created organ is coming under totally mechanical or partial mechanical or biological, that kind of the checkup will be taken over. The calibrator, the calibration, analyzing will be taking over, and then only it will be implanted into the human organ. It hardly takes almost 1 week of time. But if this 3D printer model is not available, then creation of the model is also takes 1 month or 2 months of time. So this is what the innovation is. This is what the creation is. Next, please. And then what I mentioned is, that is what? The artificial organ creation. The artificial organ, whatever the first part you've seen in orthopedics, most of the orthopedic domain, they are needed, especially for the tibia and femur and the knee detachment and the disc detachment in the spinal cords. Most of the orthopedics required are artificial organs. In Tamil, they say a plate vechirukanga. That's what the scene is. Then the second part, the cardiology. Cardiology, particularly for the 2 different types of the model organs they are created. The total organ can be replaced, or the total, instead of total organ, the part of the organ will be replaced. Particularly in cardiology, the heart is functioning superbly, but the valves of the heart is not functioning properly. Then the artificial valves will be implanted. That will be created by the 3D printing model. Within 1 hour or 2 hours, that will be created. As like us, because the creation of valves is entirely different from person to person. It is according to the tissue functioning. The functionality is same. But the DNA, RNA, the basic, the internal study is entirely different. The cell biology is entirely different from person to person. That makes curiosity, that makes study, and then only you are supposed to creating the valves of the heart, like that. And then the next part, the most needed part is nephrology, dialyzer. The first 3D printer model is created in the year 1988 by Dr. Dolph, by Dr. Fall. He's the father of artificial organs, creating an artificial dialysis. And then it will be created some of the organs. Nowadays, the organs are implanted. Okay, next please. So these are all the familiarized artificial organs nowadays, my dear. Most of them in an abdominal and cochlear transplant, cochlear replacement in ear, bionic eye, and then replacement of artificial organ, artificial liver, artificial kidney, artificial stomach in some cases, artificial blood vessels, artificial valves. All these things can be artificially made by using the 3D bioprinting model. Without 3D bioprinting model also we can create, but it takes time. Next, please. So all these innovations, the future enhancement is totally dependent on AI. All the 29,000 biomedical equipments are going to play a main vital role by using a new technologies called AI. Every domain required AI, but the healthcare support, the healthcare AI is entirely different. So everyone should know about the artificial intelligence, machine learning, deep learning concepts behind the healthcare. Because nowadays, most of the ultrasonography machines, especially you can able to take a mind ray, you can able to take a sonar machine. The sonar ultrasound machine is very portable. Sonar ultrasound machine is very portable. All are AI based. The Mindray company, the company called Mindray, they are totally for imaging equipment creation. The company from China, they are creating almost 100 plus equipments on the basis of AI technologies. So what I'm telling is GE Healthcare, Siemens Healthineers, all the tier 15, all the tier 1 biomedical companies, they start manufacturing their products using the AI technologies. So every biomedical engineer should know about what is the basics of AI, machine learning, deep learning. That is very helpful for creating the medical robots, because the robots play a main vital role. The doctors in 2027-30, the doctors are replaced by the robots. That is what all happened, because healthcare nowadays in India is concerned, we are giving a preference to the doctors in the first part in the healthcare. But once the year is going on, the equipments play a main vital role. The secondary, tertiary part only the doctors come into play. So the equipment is nothing but a biomedical engineers. Next, please. So that's all about my topic. It is 1 hour. I can able to cover this much particular topic. So these are all the innovations available. These are in particularly in deeply you can able to talk. Nano robots are there. The small pill is there. Nano robots. Okay, all these things are play a main vital role for the innovation technologies in healthcare concern. So only domain called the healthcare, in particularly called biomedical equipments, diagnostic tools, and the therapeutical equipments. All these things are very fastly developed as a cancer tissue. The multiplication of the innovations or come around where you can, if you have a chance to visit FDA, Food and Drug Administration websites, in that you can choose a medical devices column. You can get all the information regarding all the articles, innovations from every part of the world. Okay, that is what I need to share. And I will play one of the video on the light out everyone see. I will show some of the recent innovations. In some of them, having a keep on you are following LinkedIn. You can see that. I will share some of the video in it. Okay. இதுல இருக்கா? Wait a minute. இதுல share பண்ணணுமா? இதுல share பண்ணு. Wait a minute, please. At IIT Bombay have some of the setups for creating the medical robots technologies.
Okay, okay.
Yes, madam.
But manufacturing side nil in India.
No, madam, not yet.
Not yet.
In my conscience, I don't know that. Because we are also searching for it, madam. But still now there is no medical robotic manufacturing sector is there here.
Similarly, no usage also. Even though anything is.
Yes, madam. In the hotels and for the other purpose they are using, madam.
Okay.
But for the healthcare, it is not yet started in India.
Okay. Okay, sir. Thank you.
Yes, madam. Thank you.
Sir, I had a question.
Yeah.
So I actually saw this particular news day before yesterday, I think, the embryo thing. You think it's feasible? Like, will it come into existence completely?
Yes, madam. Because once you saw the video from the starting to end, and at the same time, they are giving a website link also. You can go and study about each and everything. Most probably, in my conscience, 99% it is accessible only, madam. Because it has happened. Because everything, whatever the corner and whatever the area you are going to look out at, they are having some of the aiding support on it. So 99% it is feasible.
Thank you, sir. But I think it's completely against nature as well.
Yes, madam.
Yeah, thank
That
you.
is why the engineers are now not only creating the equipment, they are creating the babies.
Yeah, but I think it might help for the current generation, who are against marriages and stuff, but need their own kids, might be helpful for them.
Yes, madam.
Thank you, sir. Thank you so much.
Thank you very much, madam.
Prem, sir.
Delegates, any other questions? Okay. Yeah, on behalf of Satyabama Management and Department of Biomedical Engineering, I would like to extend my special thanks to Dr. ATHEENAPANDIAN sir for inspiring us with the lecture on advanced biomedical innovations. So this lecture certainly benefited from your breadth of knowledge and depth of expertise, sir. Thank you for your valuable time. We are very most grateful to you, sir.
Thank you very much.
Yes, sir. And I also extend my big thanks to our delegates for patient listening and active participation in this event. And I also request the delegates to kindly share your feedback link also. Thank you, sir.